2. So today we've got Unit 2A, Day 1. I want to say, 8-9 days section, unit, something like that. I think there's 7 days of stuff, and then a quiz or something, day of review. But it's all about quadratics and how we graph quadratics that are in different forms. So we're going to talk today about graphing quadratics that are in vertex form. Tomorrow we'll talk about graphing quadratics that are in standard form. We're going to talk factoring, everybody's favorite thing to do, factoring. You've seen the X method before if you had Pazuric or if you had Winter or me or whoever. You've seen the X method of factoring. We're going to talk about the quadratic formula. We're going to talk about a bunch of different things as far as quadratics go. And again, quadratics are parabolas. Okay, so we're going to look at the parabolas. So one of the nice things about this is we kind of studied some of this in the last chapter. So on the test that you took on Thursday, and no, I don't have it corrected yet. I took the weekend and worried about the cross-country kiddos, and now I'm done worrying about them. No, I'm never done worrying about them. But I don't have that anymore. We'll talk about that in a minute. So you get your test like tomorrow, I hope. Okay, so, but we did this. This was part of your test. Okay, and this is a quadratic. Okay, so the warm-up today says for each function, identify the parent function and then state the transformation and sketch the graph. So kind of like one we were given, f of x is equal to 2 times x plus 1 squared. So that part of it, when we hear the squared right there, tells us that it's a quadratic or that it's a parabola. So our parent function is a quadratic, or we put f of x is equal to x squared. That's kind of the parent function itself. The transformation, we talked about left, right, up, down, those different types of things, but this is going to go right or left. This is going left 1, which if we're thinking about on the coordinate plane, left 1 means negative 1. And it's going up or down? Down. So it's going down 3, which again, if we think about it on the coordinate plane, down means negative. So it essentially means if we're going to sketch the graph of this, we've got this point at negative 1, 3. Now, does this graph go up or does it go down? Is the a value positive or negative? It's positive, right? So if it's positive, this is going to go upwards. So it's going to look something like this. And that was kind of a sketching these graphs. And that's what we did in the last chapter. Today what we're going to do is we're going to put a name to this form and then find this piece right here. And then a couple other pieces as well. So some definitions in some words, because we like words in mathematics. A quadratic. A quadratic is a function where the highest power is 2. I have another job. Yes. Anyway, so a quadratic is where the highest power of the exponential is 2. So it's this squared piece of it right here. Okay. Big time for your notes, vertex form. This is what we call vertex form. And we call it vertex form because we can easily find the vertex if we're given something, an equation or function that's in this form. That form is y is equal to a times x minus h squared plus k. Where the vertex is going to be our HK value. And if you think about the one we just did, the left and right, up and down, that gave us our vertex. So that vertex is the HK value in there. Now, understand, This down here is our vertex. Okay, so this point right here is our vertex. So we're going to put a little dot there, and I want you to draw this because we're going to put a couple other things here. That part of it is called the vertex. If the equation is in vertex form, that's the HK. So it's the opposite of what you see in parentheses and what you see. And we'll do an example in just a second. There's another line that's formed as well. It's this line right here. This line right here cuts the graph into two really kind of corresponding parts, or symmetric parts. So that part, that line right there that I created is what we call the axis of symmetry. Two M's or one in symmetry? That look right? Yeah, sure. We'll go with it. They told me it was this, so. English, I'm a math teacher for a reason. So that's called the axis of symmetry. Now here's the thing with the axis of symmetry. The axis of symmetry has to go through the vertex. Okay, so that axis of symmetry is actually going to be the equation x is equal to h. So this, and this are all always going to be the same thing. Okay, it's called the axis of symmetry. Now, when something is symmetric, that means that it looks the same kind of on both sides. We're kind of symmetrical, sort of. But what that also means is that if I draw a parallel line to my x-axis, and I draw another parallel line over to the other one, that the distance from the axis of symmetry to each point on the parabola is, sorry for the geometry reference, they're congruent to each other. So if I know this distance is 3, this distance is going to be 3 as well. That's what symmetric means. It means that it's going to be the same distance as long as we draw a line that's parallel to the x-axis. It's going to be congruent on each side. That's going to help us graph these, because eventually what we need to graph quadratics is we need 3 points. We're all going to find the vertex. That's easy to find. And then we're going to have to find 2 points here eventually. Okay. The other thing we need to talk about is we need to talk about max and min. Is this a maximum graph or a minimum graph? Okay, when we're talking about maximum, you talk about how high something goes, right? If you talk about minimum, we talk about how low it goes. So does this go high or low? Okay, it's a minimum. When we're talking about the maximum or minimum, we're always talking about the vertex. So that vertex is at a lowest point. So we say that this is a minimum graph. It goes down to a minimum depth. That is always going to be the minima is going to be y equals k. Or it's just going to be your k value. It doesn't have to be y. It's not really a line. It's a point. But it's the k point. So this here, and that there are the same things. They're the same numbers. Okay. So what we want to be able to do is we want to be able to be given something in vertex form, and we want to be able to graph it. Before we do that, however, I want to look at a couple things, other things, and kind of walk you through a problem if we can see it. Now, don't even try to write this down. Just kind of watch, because this is way too much. You'd never be able to get this into your notes. It would be too much. But here are the different parts of a parabola, and this will be in the notes. So parts of the parabola. First part is the axis of symmetry. The axis of symmetry is the line that goes through the vertex vertically. So it's that line right there. In order to do that, I like to find the vertex first. The vertex is the highest or lowest point of your graph. So my vertex is right there. So my vertex for this graph is -1, -4. That's my vertex. The axis of symmetry. We said the axis of symmetry was my x value at the vertex. It was my h value. So in this case, my axis of symmetry is x is equal to -1. So it's this line right here. Now, does the graph open up or down? I mean, it's pretty obvious it opens up, right? So, is this a maximum or minimum graph? This is a minimum graph. So it's a minimum graph, and its y is equal to -4. Or just -4, doesn't matter. The next two things are what are called the x-intercept and the y-intercept. And right now, the only way you could find the x-intercept and the y-intercept is by looking at the picture and understanding what it means to be the x-intercept and the y-intercept. The x-intercept is where your graph crosses the x-axis. So if we look at this parabola, it actually crosses the x-axis twice. It crosses at -3 and it crosses at 1. So we say the y-intercepts, or the x-intercepts for here, are -3, and that's going to disappear, are -3 and 1. That's where it crosses the x-intercept. And that's something we're going to work on this chapter. How do I find it if it's not graphed for me? The y-intercept is where your graph crosses the y-axis. So here's my y-axis. Here's where it crosses. It crosses at -3. So my y-intercept in this case is -3. Nothing to do with, those aren't going to be the same all the time. They can be, but most of the time they're not. Next thing is domain and range, just for review. Remember that a parabola, a quadratic's domain is always -infinity to infinity. Left to right. From the smallest number to the largest number. The range for this, will you just stop erasing? The range for this is my lowest value, which is -4, to my highest value, which is infinity, because it goes up and up forever and ever. Okay? So those are the different parts of a parabola and the different things by the end of this chapter that we want to be able to find. Today, what we're concerned with is okay, if I'm given an equation that's in vertex form. So for your notes, we're going to go y is equal to x minus 3 squared minus 4. We want to be able to find all of these different things. We want to be able to find the vertex, the axis of symmetry, the direction that it's opening, its maximum or min, and then its value, the domain, range, and more points. So the first one we always find is the vertex. So the vertex is always going to be the form HK. If we were talking about the translation to this, is it going left 3 or right 3? Right 3. So that means it's going to be +3. Is it going up or down? Down, and it's going down 4. So my vertex for this is 3, -4. That's my vertex. If you have to think about it of how you're doing the translations in the last chapter, just remember that right is positive, left is negative. Up is positive, down is negative. And you can find the vertex. So I like to go ahead and graph that point, 3, -4. So if you're just sketching it, which you're going to do, it's down there somewhere. Axis of symmetry. The axis of symmetry is always x is equal to h. Well, my h value, my h is here, so that has to be the same. So my axis of symmetry is x is equal to 3. That's my axis of symmetry. Again, those things are all going to be the same. So if I draw in that axis of symmetry line, that axis of symmetry line looks just like that. Direction of opening. Direction of opening, we look out front of the parentheses. If it's positive, it goes up. If it's negative, it goes down. So this is going to go, it's positive, so it's going to go up. So I'm just kind of sketching my graph. So direction, this is going to go up. Maximum or minimum? Vertex is at its lowest point, so what is it? It's minimum. So this is a minimum. Its minimum value is going to be our y value, so our k value. Our k value is -4. Okay. So our k value is -4. It goes right there. Now the domain. Domain is always -infinity to infinity for these. If you get one thing right on the test, it should be the domain of these. It's always the same. Range is from our lowest point. Our lowest point is our k value. So that is going to be the same as all those other things in pink. And then it goes up and up forever and ever. So it's going to go up to infinity. So now the new one, saying more points. Well, here's what we know. We know it's symmetrical. So the nice thing about it is I can say, okay, what if I let my x value equal 0? I've got my x value for a point. So what I do then is I go into my equation, my original equation, and anywhere I see an x, I'm going to replace it with a 0. So that's 0 minus 3 squared minus 4. So that's -3 squared minus 4. -3 times -3 is 9. 9 minus 4 is 5. So I know that the point 0, 5, that has to be part of my graph. So 0, 5 is right there on my graph. So we talked about then that if I have that 0, 5, if I go over that many units, I'm to the line of symmetry. How many units have I gone over? I've gone over 3 units. So if I go over another 3 units, I'm going to get to another point out there. My y value is not going to change. My y value is 5. What's my x value now? Well, what's 3 plus 3? That's my other point on the graph. So if you find one point that you know is on the graph, just by using substitution, you can figure out what that other point is going to be. So then I can a little bit more accurately draw what this graph looks like. Okay? And you could a little more sketchy graph it if you wanted to. Okay? So those are all the things that we want to be able to find today when we're graphing in Vertex 4. Questions with that one? A lot in there, I know. We've got 2 more examples that we'll do together. We'll do one more together, and then the last one you can do on, see if you can do it on your own. All right, so here's our next one. Same directions, but now our equation is y is equal to negative, and then parentheses x plus 2 squared minus 5. Do-do-do. So what's my vertex? I'm going left 2 and down 5. So -2, -5. It's barely on my little graph, but again, if you're just sketching it, it's down there somewhere. Axis of symmetry. X is equal to? What is it? Remember, it's x is equal to h. -2. Direction of opening, up or down? This is going to go down. I'm going to draw and I should have done this right away. I'm going to draw that axis of symmetry line in. This kind of helps me visualize it. Okay, so this graph goes down. So it's going down something like this. So is that a maximum or minimum? It's a maximum. It reaches a maximum height. It's the y value. So our y is -5. And again, remember, these two things correlate. These two things correlate. Domain, it's always the same. Negative infinity to infinity. The range, remember what range means. Range means from its lowest to its highest. What's my lowest point here? Negative infinity. What's my highest point? -5. A bracket, technically, if you put a parenthesis, whatever, I don't care. Okay. So we've got the domain, we've got the range taken care of. Now we're going to go more points. I'm going to use x is equal to 0. It's the easiest one to use. You don't have to. If it's on x equals 0, obviously you can't use it. Use 1. I plug it in. So it's -0 plus 2 squared minus 5. So that's -2 squared minus 5. 2 squared is 4. So that's -4 minus 5, which is -9. Okay, so there's my point. Does it make sense that it's way down there? The graph is going down, right? If you got an answer that was 4 and you said it's this one up here, would that even make sense? Because your graph's not going that way. So make sure it makes sense. It makes sense. Enough anyway. Okay, so that's not what I wanted to do. So it's down here. So now, this distance right here, you're essentially looking from the distance from 0 to -2. So that distance is 2. What's this distance going to be? 2. So my other point, my y value is going to be the same. It's going to be -9. What's my new x value? -4. So there are my answers. Isn't math so much fun? Because the distance from here to here is 2. From 0 to -2, that distance is 2. So it's just from 0, just my x values. Okay. Good with that one? Ready to try it on your own? Good. Thanks. Good. Because you are. I know the answer to that is that. All right. Find those things for that graph. What's that? I didn't put it up until last hour. My gosh. You did it. I'll show you how the girls would do. Okay? Ooh, interweb went down. What? It is an hour off. That one's right. It's 3:05 with my picture on it. That one says 4:05 right up there. This one's right. It's the only one that matters.
Yeah, but I don't look at that one.
Well, don't look at that one. It's wrong.
Well, fix it.
It's not mine. It's the schools. Blame them. They should have people that come around and fix them for us. Yeah. We ready? Vertex. Negative 4 comma negative 6. Wow, that's really close to my graph. It's down there. Axis of symmetry. X is equal to negative 4. Up or down? Is this positive or negative?
It's up.
So it's going to be up. So it's a max or a min? Min. Min means low. So it's a minimum. What's the value? Negative 6. Domain, negative infinity to infinity. Range, what's my bottom number? Negative 6. What's my highest number? Infinity. More points, so we're going to use 0. So that's 2 times 0 plus 4 squared minus 6. So that's 2 times 4 squared minus 6. Order of operations, follow it. I have to square first. So that's 2 times 16 minus 6. 32 minus 6 is 26. So I've got the point 0, 26. Okay, so I didn't draw the axis of symmetry line in there. I should have. So it's going to go way up there somewhere. Okay, so we can pretend that that's the point. So we're down here. This point way up here is the point 0, 26. I've got this axis of symmetry line. What's that distance? You don't need the graph to see it. What's this distance right here? What's this distance right here? What's this point? This point down here is negative 4, negative 6, right? What's the distance from negative 4 to 0? 4. So that's 4 units. From negative 4 to 0 is 4 units. So that means I have to go another 4 that direction. So not positive 8, negative 8. 26. Because we have to go, we're going in this direction. Negative 4 and negative 4 is negative 8. Just add those two things together. And just remember it's negative direction, not the positive direction. Okay. Those are our answers. Okay, so this is what you're going to practice today. You're going to practice graphing quadratics in vertex form. There are 6 questions on your assignment today. All 6 questions look exactly like this one. Oh, not exactly. I mean, they have different numbers, but done in the same way. The answer key is there as well. So you should be able to check your answers to make sure you're good to go with that. Okay. Any questions, comments, concerns, angers, griefs? I don't take angers or griefs, so. So no.